we're going back to capsules because capsules will allow us to go further and go do the long duration exploration missions out beyond low Earth orbit, and they have heat shields, and they're not meant to fly back in. They're meant to come back in with the heat shield and actually parachute back into the ocean in this case. Well, we've got commercial vehicles that are being built right now, which is really exciting because we may have in the next year 2 commercial vehicles taking humans to the International Space Station. Orion 2022 should be the 3rd U.S. vehicle that's going to take humans from U.S. soil out into space. No country has ever had 3 human-rated flying vehicles at the same time. So this is absolutely amazing, exciting times in the space business. And Orion, what's different from those low Earth orbit vehicles is their heat shields only have to be able to come back at about 17,500 miles an hour. Okay. But when you get going to the moon to be able to escape Earth's gravity, go to the moon, come around the moon, and back to Earth, we're talking a lot faster speeds. So instead of like Mach 25 is what we come back in from low Earth orbit, we'll be coming back in Mach 32 and Mach 35. And so the heat shield has to be that much more robust. It also has to be more radiation hardened because we're going outside the Orion radiation belt. Has to have a strong communication system because we're going, transmitting from 250,000 miles away instead of 250 miles above the Earth. So there's all types of systems that are aboard Orion that allow us to do that. And then that'll be the place where we have Orion will go to the Gateway and build the Gateway space station in lunar orbit here in the 2020s. So now we've got a spot to be able to do lunar exploration, sustained human presence on the moon, as well as maybe start building our Mars-class vehicles that'll take us to Mars in the 2030s.
There's a lot going on at NASA.
There's a lot going on at NASA.
And we're making big progress, and that's one of the reasons we're here today.
Absolutely.
It's so exciting. Another question that I think is kind of funny is a lot of people have been saying, is it attitude or is it altitude? And it's attitude. So what is attitude? Can you guys explain that?
So sure. So attitude is sort of the orientation of the spacecraft in 3-dimensional space. So altitude is the height, attitude is the orientation. So therefore, our motor, 8 different directions, none of those directions are sort of down towards Earth. That's what's determining. The Abort motor is giving you attitude or altitude, and this motor is giving you the altitude.
Mm-hmm, mm-hmm. And what makes this motor in particular super unique?
It is a solid rocket motor. It does have the 8 different valves, and it's a very complex system that goes into deciding how and when to open those valves and make each of them function when they're supposed to. Mm-hmm. And it's a human-rated solid rocket motor for those designs.
Yeah, that's so exciting. Are you excited to be a part of it?
I'm definitely excited.
Me too. So how do 8 valves steer the aircraft? When do you guys answer that? That's a question from our social media audience.
Sure. So there are 8. They're positioned, in 1 in each eighth of the section. And depending on what they need to do, they'll command which direction it needs to go. And the hot gas will come out each of those 8 valves, and that'll pivot it in the opposite direction.
Mm-hmm. And so basically, if this is the Abort motor, the valve opens up here, it's going to push it this way. And that's no different than any of the other reaction control systems on any of the spacecraft, or even the jet packs that we wear on our spacesuits when we do spacewalks, except we use compressed nitrogen instead of solid rocket motors. But all it does is open the valves, and that then pushes you in the opposite direction. And that's how you control your attitude in space when there's no gravity.
Cool. So cool. All right, we can take, I think, one more question from our social media audience. And Comrade, this one is for you. So NASA's working with commercial partners to get astronauts out of Earth orbit and into low Earth orbit, excuse me. But how does the launch abort system differ from other spacecraft?
Well, the other spacecraft that are being developed right now, they carry their launch abort system with them on their capsule the whole time. And so they take it up, even when they get in low Earth orbit, they have it with them, and it comes back downhill with them. And so what's neat about this one is, well, as soon as we don't need it anymore, we can get rid of it, and then that extra weight we were carrying, we don't need to carry when we need to fire our motors to do the trans-lunar injection burn and get to lunar velocities and escape Earth's gravity.
Cool. Awesome. Well, we're about to go to the test. Stay with us, watch it, and come back and send your questions into us. We'll be back for a quick recap.
See you soon.
We did it.
That
That
was
was a successful
awesome.
test. Yes.
That's awesome.
It was so awesome.
Congratulations.
Yes, congratulations, Alicia Bet. That was amazing to watch. Now, tell us what we just saw.
Sure. So we, ran a duty cycle to show that we could open each of the valves and that the flame would come out where it needed to, when it needed to. And so that's what you saw was the rocket motor's burning the whole time. There's always flame coming out. It's just deciding which valve that it comes out of.
What were you thinking when you were watching it?
I mean, honestly, it was just like, it's working. I love it. I love watching a test. I love, that moment of fire and seeing all the work that everybody here did and seeing it come into fruition.
Amazing. Congratulations.
And then 7,000 pounds of thrust on that motor. You didn't have to get very close to roast your marshmallows on that one. That was a pretty big flame coming out of those those ports.
Well, it was successful, so that's great. And what does this successful test mean for us?
Well, I mean, we've got 3 of these tests. This was the first one, right? We're going to have 2 more later this year. And with that, by the end of the year, this launch abort system is going to be fully qualified. The neat part is we've got in June 12th, we're going to have AA2. That's an abort test number 2 for Orion, where we're going to take and launch up an Orion capsule with the launch abort system on top of it. And right at the maximum dynamic pressure, the hardest part where the air's getting compressed just before we get to supersonic velocities on a launch, we're going to go ahead and fire this launch abort motor and pull Orion away from the rocket to test the whole launch abort system. And so that's going to be huge. And then these remaining tests for the qualification modules will then make the qualification complete for when we have EM2, the human-rated, Orion capsule that's supposed to launch in summer of 2022. Well, that'll be qualified to put the people have the people inside of Orion and provided them safe access to space and an escape if they needed it. Ideally, our friends here at Northrop Grumman have done such a phenomenal job. We'll never need their system, and it'll be able to jettison. We'll be able to look out the windows of Orion and be able to see the trajectory, heading out into low Earth orbit and then onto the moon. But we know that it's there if we need it, and so we're very appreciative for the work that they're doing.
I cannot stop smiling. I'm so excited. Yeah, it's amazing. That test almost looked better than us in our blue lab coat.
Yes.
So awesome. So we have some questions from social media, and one of the questions is for you. Did all 8 valves work correctly?
So obviously, we gather a lot of data. There's a lot of instrumentation during this course of this test. We'll go back and we'll look at that, and we'll make sure that all that data looks exactly the way we expected. Visually, it sure looks like they did, but we'll go back and look at all that data.
That was a cool visual for sure. Now, another one is, I guess for you, comrade, how much thrust is produced in any given direction?
I'm going to have to defer to our experts from Northrop Grumman. I'm just a stick monkey.
Yeah,
so,
sure. That 7,000 pounds that was mentioned earlier, that is capable in one direction.
Okay.
And so if more than one valve is open, it gets dispersed and divided.
Right.
Okay.
So yeah, you can, when they're commanded, they'll sort of command the 3 valves or so in that one direction, so you'll get a little more.
Awesome. Awesome.
That's amazing. Cool. Well, do we have any more questions from social media? All right. Well, thank you so much for joining us today. That was so great and so awesome to see. And I just want to thank you, comrade, and you, Alicia Bet, for joining us. And thanks to Northrop Grumman for hosting us here. We can't wait to show you more of our progress with the Orion spacecraft. So keep in tune with our social media, and we'll share more of that as we go on. So thank you for joining us.
And make sure you're there June 12th when we take the whole stack and launch it off a rocket out of the Kennedy Space Center.
Yes. All right.
Bye-bye.
indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface. Beautiful, just beautiful. Oh, geez, that's great. Is the lighting halfway decent? Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface. Beautiful, just beautiful.
The Orion spacecraft for Artemis 1 is on the move, critical hardware for Artemis 2 is delivered, and a new telescope to study our Milky Way. A few of the stories to tell you about this week at NASA. Engineers at NASA's Kennedy Space Center in Florida moved the Orion spacecraft for our Artemis 1 mission from the Launch Abort System facility to the Vehicle Assembly Building. Then Orion was placed on top of the Space Launch System or SLS rocket and joined the other flight hardware already stacked and ready for the upcoming Artemis 1 mission. Artemis 1 will be an uncrewed flight test of Orion and the SLS as an integrated system ahead of crewed flights to the Moon. Under Artemis, NASA aims to land the first woman and first person of color on the Moon and establish sustainable lunar exploration in preparation for eventual human missions to Mars. Teams in Germany that helped build the Orion spacecraft's European Service Module, or ESM, for our Artemis 2 mission recently prepared it for travel to our Kennedy Space Center. The ESM stores Orion's propulsion, thermal control, electrical power, and critical life support systems. Orion arrived safely at Kennedy and was transferred to the Neil A. Armstrong Operations and Checkout Facility to be integrated with other Artemis 2 hardware. Artemis 2 will be Orion's first spaceflight around the Moon and back with astronauts. NASA has selected a proposal for a new gamma-ray space telescope called the Compton Spectrometer and Imager, or COSI, that will study the recent history of star birth, star death, and the formation of chemical elements in the Milky Way. Out of 18 telescope proposals that our Astrophysics Explorers program received in 2019, COSI is the only one selected to continue into development. It is expected to launch in 2025.
Undocking confirmed. Soyuz MS-18 is now free of the International Space Station.
On October 17th, a Russian Soyuz spacecraft carrying cosmonaut Oleg Novitsky of Roscosmos and Russian actress Yulia Peresild and producer-director Klim Shipenko landed safely in Kazakhstan just hours after leaving the International Space Station. The 7 people remaining on board the station include NASA's Shane Kimbrough, Megan MacArthur, and Mark Vandehei. The station is scheduled to get 4 more occupants later this month, with the arrival of our SpaceX Crew 3 mission, currently targeted for launch on October 31st. On October 22nd, a Russian Progress supply spacecraft that had undocked from the space station's Poisk module 2 days earlier redocked, this time to the station's recently installed Nauka multipurpose laboratory module. The maneuver provided an opportunity to test and check out systems in the new module that are used for orientation control of the station. NASA is sharing OpenET, a powerful new web-based platform that uses publicly available data to help those who rely on water resources across the drought-stricken western U.S. OpenET measures evapotranspiration, the combined process by which water is transferred to the atmosphere through evaporation of surface water on land and transpiration of moisture from plants. The tool puts NASA data into the hands of farmers, water managers, conservation groups, and others to accelerate improvements and innovations in water management. On October 19th, we held a ceremony at Ellington Field near our Johnson Space Center in Houston to name the hangar there that houses the agency's T-38 astronaut training jets after late astronaut John Young. Young was a member of NASA's second astronaut class known as the New Nine. He walked on the moon during Apollo 16, commanded the first space shuttle mission, and became the first person to launch into space 7 times, 6 from Earth and once from the surface of the moon. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan. Shedding light on black holes. Presented by Science at NASA. Black holes is one of the most highly searched terms about our universe. There's a fascination with the idea of a region of space having a gravitational pull so strong, nothing can escape its deadly grasp, not even a sliver of light. Well, not quite. In fact, much of what we think we know about black holes turns out to be myths. Myth 1. All black holes are black. As this photograph from the Event Horizon Telescope demonstrated, light can be detected near a black hole's event horizon. This is the boundary between normal space and the space affected by the black hole's gravity, from which no escape is possible. Part of this light comes from the black hole's accretion disk, a flat pancake-like structure composed of dust, gas, and other debris. Friction constantly moves the disk's material inward toward the event horizon. Light also comes from jet streams, which propel matter outward along the disk's north and south poles. Myth 2. All black holes are about the same size. Black holes actually come in several different sizes, which are defined by their mass. Small black holes are usually the result of a relatively short and violent collapse of a star. Recent work suggests that intermediate black holes are found in the nuclei of some active galaxies. Supermassive black holes, on the other hand, are found at the center of nearly every galaxy. Dr. Dan Evans, an astrophysicist at NASA headquarters, says, "There's a direct relationship between the beginning of supermassive black holes and the beginning of their corresponding galaxy. This strongly suggests the two were born about the same time and slowly grew in size together over billions of years." Myth 3. If you get within a few thousand miles of a black hole, its supergravity will pull you into its center. It turns out, you can get surprisingly close to a black hole. If you approached a black hole with a mass equal to our sun's, for example, you could get as close as tens of miles. So imagine if we replaced our sun with a black hole of the same mass. All of the planets would continue to revolve around it at exactly the same speed and distance as they do now. Myth 4. Once inside a black hole, nothing ever comes out. Nope. It turns out that radiation can escape from a black hole. One of Stephen Hawking's contributions was a theory that a black hole is not so dense in a quantum mechanical sense. The slow leak of what's now known as Hawking radiation would, over time, cause the black hole to simply evaporate. The image from the Event Horizon Telescope confirmed what Albert Einstein's general theory of relativity predicted over 100 years ago, that a black hole's form is that of a perfect circle. And as scientists learn even more about the properties of this gigantic cosmic mystery we call a black hole, they'll be able to puncture even more myths. To hear more true tales about black holes and other mysteries of the cosmos, visit science.nasa.gov. A spacewalk outside the space station